The upside in these scenarios is that we can offer a solution that optimally takes advantage of the hardware platform's offerings, resulting in faster processing while using less battery.
On this episode of Embedded Insiders, Alexander Kane, Skyworks Solutions Senior Principal Artificial Intelligence Systems Engineer, joins the podcast to discuss his company's advanced AI noise suppression, designed to reduce noise in a variety of environments and applications. Next, Rich and Vin are back with another Dev Talk, joined by Ron Konezny, the CEO of Digi International. To switch things up, they're discussing how professionals like Ron got their start in the industry, how they've kept their momentum, and giving us just a little bit more so we can get a glimpse into their daily lives. But first, Rich and Ken are discussing the accelerated convergence of AI, IoT, and embedded systems.
Good afternoon. Welcome to the Embedded Insiders podcast. I am Rich Nass, and I'm the EVP of Embedded Computing Design. I'm here with Ken Biota, the technology editor, senior technology editor. Yeah, you're a senior guy. You're pretty old. Senior technology editor for Embedded Computer Design. How you doing, Ken?
I'm all right. Every time we get on one of these podcasts and we have to do the greeting, it's always this internal debate for me. Is it good morning? Is it good afternoon? I think I'm going to start doing the Jim Carrey from Truman Show thing. Good afternoon, good evening, and good night, and just move on.
Well, when I do webcasts, I actually say that. Good morning, good afternoon, good evening, because you don't know where the listener is.
Yeah.
Because, we're all over the world. So anyway,
we need a time agnostic greeting for these. We'll have to come up with that at some point.
Right. Okay, so I need to start off with the mea culpa. Believe it or not, I made a faux pas on a recent podcast. When I was interviewing Tobin Richardson and Steve Hanna, who were both representing the CSA, we were talking about their security specification, and I referred to it as the Matter 1.0 security spec, and that is actually inaccurate. It's independent of the Matter specification, and it's actually the IoT device security specification 1.0. So I apologize if I misled anybody. That's what it's really called. But I use like those things interchangeably, and I know I shouldn't. So my bad.
It happens to everybody, Rich. Don't worry. We will. Your mea culpa has really touched the judging committee, so we'll make sure that the flogging is lighter than usual.
I appreciate that. So what's new in your world?
Well, I tell you what, I don't know how new it is, but I am on a tear lately. I've decided that my current obsession is going to be, and I've talked about it, I think, even on this podcast before, this absolutely accelerating confluence of IoT, AI, and embedded systems. I was starting to really notice it moving forward when I was at CES, and it seemed very clear that NVIDIA is preparing for it at GTC, and now Embedded World. That's all anybody was doing was look at this embedded computing product, this fanless computer, and guess what? It does AI, and it's got all these IoT sensor nets and all this other stuff. Every IoT company has an embedded computer that does AI. Every AI company wants to go into. It's all happening at the same time, and I think, not to make a big prediction, but hopefully y'all only remember it if I'm right. It's all going to become one horizontal layer. Like, I think that we're all going to sort of become this fused horizontal layer because it's all relevant to functionally every vertical, and any vertical it's not relevant to yet is going to get there at some point. So I don't know. That's the tear I'm on right now. NXP had some news that came out a little while ago. We wrote about a couple of days ago. That was everything they announced was in that vein. I don't know. It seems like every news piece I see is happening here. So I've got a nice corkboard up in my office with lots of red yarn connecting the dots. My tinfoil hat is almost ready. I'm here for it.
I got the yarn. I didn't get the tinfoil hat.
It's a conspiracy, Rich. It goes all the way to the top.
Got it. Okay. Yeah, I definitely agree with what you're saying. And I think we're moving to the point where AI is more of a checkbox than a feature that's an extra special thing. It's something that's nearly mandatory, and it means different things to different people, and there's different levels of AI. We often use machine learning interchangeably with AI, and we shouldn't. But machine learning is something that's pretty much on most of these embedded computers now, where they just learn and get better through their actions. The difference to me is that they don't. What's the right way to say this? They're not outwardly looking for those actions. They're just learning and getting better. Does that make sense?
Yeah, and I think, like, certainly it's true now, and it's probably going to be true for a long time, that kind of machine learning intelligence is going to be the sort of standard. It's what's most useful to most systems. Like, I don't think getting to the level of generative is going to be particularly resource effective or useful to most companies and most industries. I mean, there's certainly use cases that people are talking about, but I think it's just too much of a heavy lift, no matter what Jensen over at NVIDIA wants to say. And I also think it's probably a intermediate, like, transitory execution of AI. I'm not sure generative is the end. I certainly hope not, because I don't know. We'll have a talk about generative AI some other time, but teasing a future episode. But I think that generative is going to turn out to be a Betamax rather than a DVD.
I would disagree with that, in that I think it'll become more of a it's just their kind of thing, whereas a Betamax was competitive with something and went away, and I don't think it's ever going away.
Sure. I don't know. I just think that if and when, or when and if, the AI code and algorithms get beyond the point of pulling from a data set and building one data point at a time, which is, how all generative AI is. If they get beyond that, people will want the new thing more than they'll want the generative. And that's why I think generative will get phased out when they come up with the next version of it. Does that make sense?
Yeah, in that context, it makes sense. And what I was thinking while you're saying that, it's sort of along the lines, at least the way I look at it, it's along the lines of when you put security into your system, it has to get to the point where it's just there, and it's not something that you actually have to actively design in. And
absolutely.
And I think AI is moving toward that same parallel, where it'll just be there, and you don't have to really think, okay, I need to design my AI in.
Yeah. It's funny that you mentioned security, because that is one of the predictions that I appear to have gotten wrong. Years ago, I predicted that that AI was going to functionally fuse with security, at least for active, like, cybersecurity stuff, and that they were going to be using a lot of AI for response and prediction and stuff like that. And that just does not seem to have happened across software anyway. And I'm still shocked about it, because I would have thought that that's a natural case for AI, because it can just move so much faster than a human, like, hacker or other bad actor could, or at the very least move as fast as a like botnet could, you'd think.
Yeah, I would say the jury's still out on that one, actually.
I'll take it.
I wouldn't be so hard on yourself there. I think as we get more into quantum computing, you're going to see a lot more of that.
I hope so. Just if for no other reason than I hate to be wrong.
There you go. Well, you're not supposed to reference the old predictions. That's the beauty of what we do. It happened a couple of years ago, and everybody forgets. We don't have to look back on what we did wrong. Only when we get them right.
Oh no, that's it. I've spoiled the game.
Exactly. Very good.
But yeah, so I think that there's a reasonable possibility that and I will not take credit for this, but sensor fusion, which you mentioned, we were talking about this the other day, seems to me it's going to be at least a catch-all term that you're going to start seeing in my articles over the next little while, because I can't keep writing AI hyphen IoT hyphen embedded in every article or I'll die.
Yeah, I agree with that. And sensor fusion is not new, but it was a concept before, and now it's becoming reality.
Yeah, I think so. I think that it's being driven by the end users, by the not just consumers, but the enterprises and the companies that want to put these things in. They want them to be more than single use systems. They want to have multi-purpose, multi-sensor, multi-processing options. And so because of that, all of it is going to become, and they don't want to have to work too hard for it. They don't want to have a ton of systems integrators and stuff working on their stuff every time they want to do something new. So I think that that it's all going to get driven by the end users going, this is too hard, make it all in one box.
Yep, agreed.
Now, here's Alexander Kane, Skyworks Solutions Senior Principal Artificial Intelligence Systems Engineer, dissecting the inner workings of advanced AI noise suppression.
I joined Skyworks in 2020 as a team lead of a newly forming artificial intelligence team. Before that, I was a professor of biomedical computer science at the Oregon Health and Science University for 13 years. I have over 25 years of experience in machine learning, over 60 peer-reviewed publications. Finally, I was also principal investigator on 8 grants from the National Institute of Health and the National Science Foundation, and participated as key person on countless more. At Skyworks, I lead the AI team, and we work on speech and audio processing presently.
So, starting off with an introduction about this AI noise suppression technology, for those who don't know what it is, maybe the listeners and those of like me, how would you explain this? Is it maybe the same as noise cancellation, which is a term we hear all the time, or maybe how do those differ, or how do they compare?
Okay, so I'll put that at the end. I'll start with saying that AI noise suppression is a term that's currently most often used in the context of speech communication. It's a process that has at its core a neural network that can separate different types of signals from a single mixed input. We train such a network to separate speech from noise, where noise can be anything from power tools, traffic, keyword clicks, dogs barking, and so on. For most applications, we are only interested in the speech, so we discard the separated noise. Perhaps unsurprisingly, studies show that listeners typically prefer to listen to speech that is noise-free, which makes the technology desirable in any context where we want to provide the best possible speech communication experience. But in some applications, we may want to add a degree of noise back into the output, or perhaps even keep the noise and discard the speech signal. It's probably most useful for devices anywhere speech is received or transmitted. The first devices that enabled this technology were personal computers, because the first versions of this algorithm were relatively memory and compute intensive. For example, most popular video conferencing and game chat systems were the first to add AI noise suppression. Of course, mobile phones have also started to adopt this technology, and we are very recently also seeing the beginning of the availability of AI noise suppression at the edge, where by edge I mean lightweight peripherals or sensors that previously had no or very little compute power, such as microphones, headsets, conference systems, or portable speakers and communication radios. In acoustic noise cancellation, we acoustically cancel noise by inserting negative phase waveforms from what is happening outside, but it would block speech as well. So if you had a communication partner and you have ANC on, they would also be suppressed. In contrast, our technology is selective about what it's suppressing. And currently we are training it to keep speech signals and reject anything that's non-speech.
So you mentioned mobile and desktop applications. Speaking of those, how easily can this noise suppression solution be integrated into different hardware platforms or applications like those?
Right. Since our AINS, which stands for AI Noise Suppression Solution, is completely self-contained, that is, it does not depend on other software components or the internet, integrating it into an existing software application is relatively straightforward. One would follow standard practices. However, to bring AINS to a new embedded hardware platform takes a little more time, since most types of real-time AI tasks need to be run near peak efficiency of the hardware, which in practice means getting to know and then capitalizing on a specific feature set of a given hardware platform. That said, our team has a wealth of experience in bringing different types of algorithms to many different platforms. The upside in these scenarios is that we can offer a solution that optimally takes advantage of the hardware platform's offerings, resulting in faster processing while using less battery.
So, going as high level or low level as you would like, can you explain maybe some of the key techniques or algorithms that Skyworks uses to achieve the high performance operation of the solution in or on embedded systems?
So I would actually say that our key techniques are experience and perseverance, which might sound like a joke. And it is my observation that having a dedicated, cohesive, and creative team makes all the difference. Speaking in more detail, we have continuously tracked the latest trends in the academic literature, adopted many industrial best practices to develop and test our code base, and frequently evaluated our product using both objective metrics and human listening tests, all the while comparing with leading commercial solutions to know where we stand. Moreover, because we control product development all the way from raw data to the final integrated system, we understand and tune every component to optimize for a given deployment target. We are proud to offer a solution on the edge that, depending on the availability of memory and compute resources, rivals or even exceeds performance of market leaders.
So, are there any or what design considerations were made to ensure that the solution operates independently without, requiring connections to the cloud or external devices, like you mentioned earlier?
The requirement to be a self-contained processing block is actually dictated by the requirement that the task itself must be accomplished in real time. In a human-to-human conversation like we're having, any processing delays must be kept to a minimum, or what is called low latency. Depending on the application, we can create solutions with a variety of processing latencies. Typically, performance depends on three factors: the available memory, available compute, and latency. Sometimes latency is not critical, and overall performance can be improved by increasing latency to, say, 30 milliseconds. Other times, latency is the single most critical aspect, and here we have solutions with latencies below 10 milliseconds. Cloud-based processing would not even be possible in such a short amount of time.
So, how does the solution adapt to different types of environments or different noise or frequencies, I guess you can say? And if you have any maybe real world examples or use cases that you can use?
We have a standard offering that we believe works well in most home and office environments. For this, we had to make decisions as to what is defined as speech and what is defined as noise. For example, is coughing important in a particular context or not? In most situations, we may not want to hear those types of noises, but in a medical context, they could be important. If a customer needs a solution with their own definition of what should and should not be suppressed, we can retrain our neural network with that definition and deploy a custom solution. In most cases, it's also possible to update existing deployments with a firmware update. As to real world use cases, we believe we have an effective solution in AI noise suppression on headsets for video or audio conferencing or gaming. AINS on the receiving side suppresses noises coming from the other person's location, whereas AINS on the transmitting side will suppress the transmission of noises on the user's location. Now, another very exciting success story is the integration of AINS into devices like soundbars or radios. Any device really that plays movies, radio broadcasts, streaming video, or similar media. We call this resulting system dialogue clarity. Imagine an action-packed science fiction movie. Pretty often, explosions and sound effects are mixed very loudly together with the actor's speech, sometimes making it hard to discern what was said. With the Skyworks dialogue clarity system, the user gets to decide how loud the background should be, completely independent of the speech volume. We have a few of these prototype systems at the office, and everybody who has experienced how it works would like to have one for their personal use already. I know I do, wouldn't you?
Now, here's Rich, Vin, and Ron Konezny, the CEO of Digi International.
Good afternoon. Welcome to Dev Talk with Rich and Vin. I'm Rich, and you're Vin. How you doing, Vin?
Good. How are you, Rich?
I'm doing good. Just back from Embedded World. What a great show it was. That's said
awesome.
There were 32,000 people there.
Wow, I didn't know there were that many of us.
Well, I don't believe the number, but it depends how you make the number, because I'm sure that includes all, I shouldn't say sure. I believe that includes all the exhibitors as well. And there were 1,100 visitors. And if you take an average, I don't know, 5, 6, 10 people per exhibitor, you're at, let's see, do the math there, 11,000 people right there. Did I do that right? Yeah. So anyway, but it was a really good show. Monday was good. Tuesday was great. I'm sorry, I'm doing this wrong. Tuesday was good. Wednesday was great, and Thursday was slow. But that's to be expected. It was a really good show. The technology we saw was top notch, and everybody wants to talk about AI and Wi-Fi 6 and security and all that stuff. So that was my week. And cool. You have been MIA. What's going on?
Oh, there's been so much craziness going on in my life. I'm actually preparing to conduct my first wedding this weekend. My wife's nephew's getting married in Arkansas, and I got ordained, and I'm going to be performing the wedding. And they want it to be funny and more secular, so it's going to be really great. We're doing a reading from Dr. Seuss and a whole bunch of other things. So I've been prepping for that in my personal life, and in my business life, I've been working on building out this course we were talking about, and doing a bunch of stuff for a couple of clients in the area of technology adoption and technology value proposition work, which is the stuff that I do when I'm not teaching. And it's been really exciting. I think we released 5 videos in the last 2 weeks for a client. So we've been hopping.
Well, I can tell by the way your office looks behind you that you've been quite busy, because it's still quite the mess. I'm sure Gail is not happy with you.
I was building circuit boards last night until midnight. So
there you go. So back to Embedded World. One of the exhibitors that I happened to meet with at Embedded World was Digi International. And it dawned on me that we have not had Ron Konezny as a guest on our podcast. So I said, hey, Ron, want to be a guest on our podcast? And he said, well, what's involved? And I lied. I told him it was easy. And we would just ask him some simple questions. And he said, sure, I'll come on. So Ron agrees to join. Hey, how you doing, Ron?
You fooled me, guys. I'm here.
Welcome, Ron. Welcome, Ron. It'll be easy.
First off, what was your take on Embedded World?
So listen, Embedded World was great. Really back to the pre-COVID days where you had a lot of activity, a lot of exhibitors, and it's just a one-of-a-kind experience to be able to meet so many customers and prospects, quite frankly, evaluate your competition, and of course, be aware of any new trends that are coming out.
When are we going to stop using the COVID reference? How many years have to pass before we stop talking about that?
Yeah, that's true. I mean, I guess we're not talking about the eclipse anymore, are we?
No.
I got a buddy who is a fairly big wig in the embedded space, and he stayed home until Monday night and flew out Monday night to go to Embedded World because he wanted to see the eclipse. I don't know. Was it that big of a deal? Ben, you're right in the path of the eclipse, right?
Well, not in the 100%. We were at like 70% here, and it got a little dark, but honestly, we had cloud cover, so we couldn't see too much. We got a couple of good shots with our phones, But it was such a craze that by the time we got close enough to think about it, because we had busy lives, we couldn't get glasses anywhere. So we didn't actually look directly at it with glasses. So we took upside down pictures with our phones and looked at it that way. So it was interesting. I had a couple of friends who were in the direct path, and they said that it was incredibly emotional for them, but they are in my group of crunchy friends, so it's hard to really gauge it right on some absolute scale.
Rich, you mentioned
Dr. Seuss while this is going on.
No. I mean, I have groups of friends, and some are, engineers and very left-brained, and some are very right-brained, and some are very emotional and, sort of the crunchy crowd. And it's interesting when they all mix together and what that looks like. But definitely, I mean, I know some people who drove all the way to Burlington. I know people who flew in to places, and I'm like, okay.
Rich, you mentioned
right,
the days of the conference. How many times in that third day is it the best day, right? By then people are worn out, they're doing something personal, or they took off.
Absolutely. And it's generally Students' Day, and it wasn't I think because it was later this year, there weren't that many students because they're not on spring break or whatever it is, or they are on spring break. And by it ends at 5:00 on the last day, and by like 3:30, people are ripping the booths apart, which is the norm. Everybody wants to get in there. So anyway, back to you, Ron. You've been at Digi how long?
A little over 9 years.
And you started as a what? In the mailroom?
Sorry, say that again.
In the mailroom?
Yeah, exactly. I started assisting the CEO, and then I got rid of him so I could become the CEO. Yeah.
Well, your name doesn't end in a vowel,
yeah.
so it's
No, so I actually, prior to Digi, I actually started in management consulting and worked with telco and computer-based firms. Back then, those industries were even more separate than they are today, and I was working for larger companies, suggesting, advising, recommending, and then the pendulum went 180 degrees for me to starting a company. So I started a company in fleet management. So built an onboard computer that went into trucks and connected them to their dispatch using primarily cellular as the way to communicate. And we were one of the first to combine GPS, cellular, and the internet back in the mid-90s. That was very novel. Netscape went public in 95. And of course, now we got buried in our pockets and our phones. But back then it was very novel. We go to these truckers and we say, hey, we got this brand new fleet management system. It uses the internet. And these truckers would be like, what's the internet? And how do I get on it? So those were back in the 14.4K dial-up modem era. And so our user interface was extremely crude, right? Because we had to be so precious with those bits that are traveling back and forth. But anyways, long story short, I grew that company, sold it to Trimble Navigation in 2011, and was a GM there for a while, and got the itch to be back in the chair. Like us, troubled CEOs, we can't possibly report to anybody. So I joined Digi about a little over 9 years ago as their CEO.
So you've been the CEO for 9 years.
That's right, which is how many years in tech world, right? With the pace of change, I mean, it's got to be at least double that in tech years.
Well, you're not in Silicon Valley, but I measure Silicon Valley years different than every place else.
That's even different.
100%.
Yeah.
Absolutely. So are you a tech guy or are you a business guy?
So it's interesting. I probably this is going to be a just disappointing answer, but I'm a little bit of both. I started off really, really liking sports.
Well, why would that be disappointing?
Well, so adaptable is always a little bit of like I can't nail you down. But I started off in sports, and I grew up like a lot of young kids. Like I'm going to be a professional. You name baseball, football, basketball. And back when I grew up, if you did computers and you did sports, that was like you were violating a religious or political doctrine, because your sports buddies would call you brain, and of course your brain people are like, why are you hanging out with those jocks? So I would code in BASIC back in those days, but I'd do it on the side and didn't want anybody to know because I didn't want to risk my reputation as a crappy athlete. But
oh my God, a closet programmer.
Yeah. So I've always had an affinity for programming and math. My dad was an accountant, and so I'm probably at my age now technically aware but not competent. But I'm dangerous enough to know how things work. And when I was in consulting, I fell in love with wireless communications. I'm like, and I just, how sometimes you have an epiphany, you have no idea where it came from. Like, we're going to be sending data over wireless. We're not going to be using it for voice. And that's, kind of fell in my love affair with starting this company. Back then, we were doing circuit switched wireless data. So we were connecting 1200 baud modems because back in those days, you paid by the minute for cellular. So you had to get that training time down as low as possible. And we were twiddling bits and just losing the difference from the last GPS point to reduce the amount of data so we could get all that data sent in that first minute and tear it down. I felt like a Russian programmer at that point. But
to be clear, you started Digi?
Yeah. No, I started PeopleNet, the successor. Digi's been around since 1985 when public.
That's what I thought. Okay.
Yep. So Digi's been around for almost 40 years. And Digi, real quickly, its original product was something called the Digi board. And I don't know if you're aware of that, but back in the 80s, personal computers were just coming on, and a lot of the establishments were like, hey, why would we want these personal computers? They're just big calculators. They can't really do much. And Digi said, you know what? We're going to need to interconnect these computers and want to remotely access them. And the Digi board was born. Now, that was a serial card that you could put in a Sun Microsystem and an IBM DOS, a Microsoft Windows, but you could network these different computers. And so the company was born with this machine-to-machine connectivity, albeit PCs and mini PCs. And then the company went public off of that in 1989. And within 2 years had this existential crisis because, of course, the Ethernet standard really succeeded serial as a way to interconnect computers. And so the company had a lot of money from selling tons of Digi boards and going public. So it went on different acquisition sprees. And in the 90s, if you looked at kind of the era chart, you'd see a lot of choppiness, different CEOs, different ways to make Digi great, and different acquisitions all over the world. And then my predecessor joined in 1999, and he came from 3Com, where his biggest claim to fame was the 56K modem. And he joined, and he's a product management type person, and he joined and was able to stabilize the company, grow the company. Then he stalled out, and that led into my era. And my era has been the solution era. We've got a great history.
When you say he stalled out, you had him off?
Well, I wasn't there, so the board at the time, prematurely retired him. And one of the challenges.
Nice way to say that.
Yeah. One of the challenges that at the end of that person's era, the biggest initiative / challenge was buying a Salesforce implementation firm to help usher in the age of the social machine. And so the strategy was, we're going to have these machines talk to Salesforce, in particular their Service Cloud, which is their customer service software, and they were going to tell the Service Cloud how they felt. I'm feeling fine. I need help. I need a software update. I need someone to come repair me. And we would usher in the day of proactive care. And it was very sexy. I don't know if you've ever been to the Salesforce headquarters. I had the honor to drink a bunch of their Kool-Aid. I mean, it's probably the best marketing firm on the planet. And, you got people, young people and skateboards and dogs and drinking fancy coffee. And you get there and they're like, hey, Ron, you're behind. I said, what are you talking about? Well, you need to sell, X million dollars of annual contract value of Salesforce licenses. And I'm like, what are you talking about? But they rely heavily on their partner network to sell their software. It's one of their greatest marketing achievements, is getting others to sell their stuff. But what happened was, we got a lot of meetings. This is back again in the 2012, 2013, 2014 timeframe. A lot of meetings at C-levels, because the age of IoT was just really gaining momentum. And we had tons of meetings, a few pilots, but $0. And like anything, the devil's in the details. You might have, let's say, Icon Fitness, who makes treadmills and bikes, using Salesforce to help manage their CRM and their customer service group. Well, they rely heavily on distributors that then sell to health clubs and private country clubs, except whoever's got a gym, hotels, right? So, but those people aren't using Salesforce, let alone the Service Cloud. So in the data coming from a treadmill, Icon Fitness really has to send that to their dealer, who then needs to go service that. So you have that age-old problem of, where's the value lie and who gets the benefit, who's paying and who's actually benefiting. But long story short, that really, they had bet big on this company they acquired, and it was going to transform the company, but that strategy did not succeed. And that led to me joining the company. Digi's had, wonderful history of providing very reliable, rugged, long-lasting, high-performing hardware. But as you know, companies that make hardware, especially in the Western markets, aren't nearly as valuable. They're still very valuable on Eastern markets, but not so much on Western markets. And so my big push with Digi is to leverage that strength and those relationships, but provide more of the solution, provide the wireless connectivity, provide the cloud, provide 24/7 care, and the kind of tongue-in-cheek, modus operandi or call for action is, gone are the days that you can set it and forget it. There was a time where you could buy something, put it in place, and it would work forever. You didn't have to worry about it. Now,
Well, that's the whole mantra for embedded. That's what embedded is.
right now you have to actively manage your solution. You can't just sign off. There's too many regulatory issues. There's too much change in security, and there's too much change in technology and business opportunities and challenges that you have to have a ways to actively, you guys are all as experienced as I am. There was a day when you couldn't remotely access software and update it. Now you can, you have a living, breathing piece of technology out there. We can't remotely download hardware yet, but we certainly can update firmware and add capabilities and fix bugs. And that's a tremendous value, right? And that allows
Why
you
can't
to
you update hardware?
well, you can't do it
Remotely.
remotely. Can't do it remotely.
Okay. All right.
Yeah.
Yeah. All
That's
right,
still an
fine.
in-person thing for now,
Okay. So what is the most successful product for Digi in the year 2030?
I think it's going to be, and I say this, both as a joke, but for real, is I think that as AI emerges and gets past this, I call it, this large language models where it's very processor energy, data intensive. I think what'll happen is it'll have children, and these will be small language models. And these will be AI at the edge, because the edge can't possibly need or consume all of the world's information to come up with, the latest recipe on how to make penne pasta, right? But let's say you've got a device attached to an elevator. It really cares about how elevators work, and it wants to know as much as it can about maybe even that maker model. It could greatly benefit from having access to this small language model that ushers in the day of, if you will, AI on the edge. But it's a much different version than we understand today. It's more machine oriented. It's much more specific. It ushers in the day of, being very predictive about performance and uptime. And one of our customers is Otis Elevator, and we provide technology inside of every elevator to provide emergency voice service, but also to connect to the motherboard inside that elevator to update its software, understand performance information and fault codes. Number one, to increase uptime, but number two is if there is a problem, which is hard to avoid, you send one person out there one time with the right skills, parts, and tools to get that job done, because you've got enough information to solve
What do
that
you think
problem.
of that answer, Vin? You know a lot more about AI than I do.
I think that properly implemented, that's actually the goal and the holy grail, right? Is that it's not going to fix itself necessarily, but to be able to dispatch once because you have enough information. Historically, we've on average dispatched, for most major things like air conditioners, elevators, large industrial equipment, two and a half times, because you get out there and then you diagnose and then you get parts out. And then sometimes when you get out, you find out that the part that was sent was for a different rev machine. And so you can fix some things, but not all. And so having more information about the state of the machine, when it was made, and, other industries have done this manually for years. If you look at the VIN number for cars, right, you can tell immediately what rev a car is in terms of spare parts and everything like that. So that when you go on a site that's an official site to order a car kit to add I don't know, Apple CarPlay to your 2014 BMW or something, it says what's the VIN number, and it says, oh, this is a late model. It uses our Model 23 instead of our Model 22 kit, and what you get is right from the beginning. And other things that are historically managed by, quote unquote professionals, that is people who've been trained to work on the elevator or trained to work on your HVAC or whatever, they're expected to go out and first diagnose. And if you remember the days of the old Sears model of sending a service person out. They came out in a van and they had multiple boards and things in there, and they would go out to the truck and say, I need one of these and two of these, and go back in and fix it. But that was when there were two different models to choose from. Now, both because people want more choice and companies want to cover more bases, there are hundreds of models, and there's no way to scale what I call the mobile inventory to be able to do that. And so knowing everything that there is to know about something before you go out and do something to it increases your chance of fixing it right the first time, right? And that's for things that you can't do remotely by just changing a setting, which you can do over the connectivity now, right?
All right, we're just about out of time here, so I have a question for Ron. I asked this question to lots of people. What's the thing that they didn't teach you in college that they should have?
Oh boy, what they didn't teach you in college they should have. Oh boy, that's a tough one. That's a tough one. I think honestly what I learned, probably not from college, but I think is incredibly valuable is, and I tell this to a lot of young people that I meet with, is don't chase money. Chase your passion, what you like to do, and try to match that with what you're good at, and the money will work itself out. If you can get those two, whatever it may be, don't do it for money. It never works out well if you do it just for money or fame or whatever. Do it what you're good at and what you like, and everything else will work out.
So how'd that baseball career work out for you?
Well, if like I coached my daughter's fast pitch softball team.
There you go.
Very good.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.